Mechanical energy. It is basically the sum of potential energy and kinetic energy. So mechanical energy is represented by the symbol E. So E is equal to K plus U, where K is the kinetic energy and U will stand for the potential energy. Let's analyze this with the help of a diagram. So we have a roller coaster. So let's say this cart is moving, and at a particular instant it is in this position where the kinetic energy is 50 and potential energy is also 50. So the total energy, which is called the mechanical energy, will be 50 plus 50, which is equal to 100 joules. And that is what we need to find the mechanical energy. Just add the kinetic and potential. Now, when it comes to the change in energies, the formula stays similar. So the formula becomes delta E is equal to delta K plus delta U, where delta stands for change. For example, delta E will be the change in mechanical energy. Similarly, delta K and delta U. So delta U will be the change in potential energy. Now let's discuss the most important topic, which is called the conservation of mechanical energy. According to this, energy can neither be created nor destroyed. It can only be changed from one form to another. By definition, mechanical energy will be conserved, which means equal at all the times, which means we can write the initial mechanical energy should be equal to the final mechanical energy, which can further be written as the initial kinetic plus the initial potential energy will be equal to the final kinetic energy plus the final potential energy. So let us use this logic to solve a small question. So let's say we have a block kept on an inclined plane. The height of the inclined plane is h. Now initially the block is at speed 0. Let's say we give the block a slight push so that the block starts to slide down the inclined plane, and eventually when it reaches the bottom, it is moving with a final velocity of v. And we are supposed to find the value of this final velocity v. So how do we approach this question? We use the mechanical energy conservation, same formula. So initial kinetic energy will be 0 since the initial speed is 0. Initial potential energy will be mgh. Final kinetic energy will be half mv square. And final potential energy will be considered as 0 since the object is on the ground. So mgh, the height will be 0, hence potential energy will be 0. So if we put all the values in, our equation will look like this. And if we try to make v as the subject, we will get v is equal to square root of 2gh. And that is how we identify the speed of the block as it is sliding down an inclined plane. Now let us use the exact same logic of mechanical energy conservation in another question. So here we go. We have a ball of mass 200 grams thrown vertically upwards with a velocity of 2. Calculate the maximum height to which the ball rises. Now we will solve this question using two methods. The first method will be the conservation of mechanical energy, and the second method will be using the Stewart equations, which are also called the Newton's equations of motion. Method number one, conservation of mechanical energy. So we have to consider 2 points here. Initial point is this, and final point is the maximum height. So according to the law of conservation of energy, this is the equation. So let's see what are the values of all the parameters. Initial kinetic energy will be half mv square. Mass is given and the initial velocity is given. So we can use half mv square to get the initial kinetic energy. Initial potential energy will be considered as 0 since the ball is kept on the ground. Final kinetic energy, how do we do that? So since the ball is going up and reaches a maximum height. Now when the ball reaches the maximum height, it will be instantaneously at rest. So for a small amount of time, the ball becomes stationary at the topmost point. So final kinetic energy will be considered as 0 and the final potential energy will be mgh. So let's put all the values in. And now let us simplify this equation. We will get v is equal to square root of 2gh. Now the value of v is given as 2 meters per second. So let us put the values in, and the value of g will be taken as 10. So this is the equation. And now if we try to figure out the value of h, we will get h as 0.2 meters. So this is the first method to solving this question. Method number two is using the equations, using the Stewart equations. Let us use v square is equal to u square plus 2as. We already deduced that the final velocity at the topmost point is 0, initial velocity is 2, acceleration is 10. But in this equation, we will put the value of A as -10 since gravity acts downwards. And if you recall, we can apply these equations only with the correct sign convention. That is why acceleration is not 10 but -10. So if you put all the values in, the equation will look like this and h will come out as 0.2 meters. So this is the second method. Here we have a pendulum bob which is released from rest 0.5 meters above its rest position. Calculate the speed as it passes through the rest position. So by rest position, the question means this point when the object is at the center. So how do we solve it? We have to conserve the mechanical energy at 2 points. So which are those 2 points? Let me label. Let's say A is the initial position of the bob and B is the final position. According to the law of mechanical energy conservation, we will write total energy at A will be equal to total energy at B. And total energy is a combination of kinetic plus potential energy. So let's write it down. Energy at B will be KB plus UB. Now, what is the kinetic energy of the object initially? It is given in the question that the bob is released from rest. So initial kinetic energy will be 0. Potential energy formula, we already know that will be mgh, where height in this case is 0.15 meters. At B, which is the centermost point, let's say the kinetic energy is half mv square and it is this V which we are supposed to find. And potential energy at the point B will be considered as 0 because we are considering the point B as our reference line. So if you remember the concept, reference line is a point where we assume the gravitational potential energy to be 0. And now let's simplify this equation. If we make V as the subject, we will get root 2gh, and let's put all the values in. Square root of 2. Let's take the value of g as 9.8 and the value of height is given by 0.15 meters. And now if we simplify this expression, we will get an approximate value of 1.7 meters per second as the answer. In the mechanical energy conservation, we are supposed to equate the initial mechanical energy with the final mechanical energy. But this approach is not applicable for every case. There are certain situations where we cannot apply this approach. So let's understand what are the conditions under which the mechanical energy is conserved. So there are two conditions. Condition number one, the system needs to be isolated. Number two, all the forces acting on the objects should be conservative. So let's try to understand each of these points one by one, starting with what is meant by an isolated system. So an isolated system is a system that is free from the influence of a net external force. So that means the net external force acting on the system should be 0. So let us try to understand this with an example. Imagine we have a ball which is falling towards the ground. So if we consider the ball only as the system, so blue ball is not an isolated object as it is being pulled down by the earth. So let me repeat why the blue ball is not considered isolated, because for an isolated system, the net external force on the system should be 0. But if you consider the blue ball, it is being acted upon by the gravitational pull from the earth, which we say is the weight of the object. And since the net external force acting on the ball is equal to mg and not 0, that is why the blue ball is not an isolated object. Similarly, if we consider the ground, Earth is also not considered an isolated system as it is being pulled up by the object. So let us understand this in detail. According to the Newton's third law, if you remember, forces are always in pairs. So let's say if the object is having the weight acting downwards mg, this mg is the pulling force applied by the earth on the ball. So according to the Newton's third law, the ball is also going to pull the ground upwards with a force of mg. Newton's third law, forces are equal and opposite, but they act on different objects. Here, one force is acting on the object, which is the ball, and the second force, which completes the pair, is acting on the ground or the earth. Now, if I consider only the ground, then we are not considering it as an isolated system because the net external force acting on the earth is not 0. It is equal to mg. That is why even earth is not isolated. But to solve questions, we do something interesting. So we'll combine the ball and the ground into one system. So if we consider both ball plus earth as one system, then whatever forces are acting between the ball and the ground that will act as an internal force of the system. So we can say that the net external force acting on the entire ball earth system will be zero. And then we can say that this system is considered isolated. So this was the first condition which we need to be careful of regarding the law of conservation of mechanical energy. Number two, whatever forces are acting on the object, they need to be conservative. So what is meant by conservative forces? A conservative force is a force for which the work done is independent of the path. So let's try to understand this with an example. Gravitational force is conservative. Let us try to prove it. Let's consider a case one where a ball is being thrown down. So have a look at this image. We have a ball which is initially at the point A and it is being thrown downwards to the point B. Distance between A and B is